Okay. Stop. Somebody say something. I can't hear you, please. What kind of support is this?
It is being
What do you say? This one. Though your audio is not so clear, but this is a pin support. Why this one is a roller support? Now, as I explained the other time, in a pin support, we have two unknown reactions. The forces along the x-axis and the forces along the y-axis for a pin support. While for a roller support, we only have one. This is forces along the y component. Now, using that principle that I told us earlier on, that R equals to 3N. Now, looking at this member, this is just a single member. You can see it's not joined anywhere. This is a single member. So N will equals to 1. But the number of reactions, for this one we have 2. For this one we have 1, making 3. So if we use this equation, our R equals to 3, our N equals to 1. Is R equals to 3N? If yes, that means the structure is statically determinate. But if R is greater than 3N, that means it is statically indeterminate. However, there's another point that is not written here. That is when R is less than 3N, that means it is unstable. So now, using this principle, that is what we're going to use to analyze all these members' support. Now, for this particular one, now, this is a fixed end here. And in a fixed end, I told us we have how many unknown reactions?
3.
3, very good. Now, the roller, we have how many?
1.
Very good. So 1, 1, and 3, making 5 altogether. But the member is just a single member. That is why our N is equal to 1. Now, if we apply that principle, that R is equal to 3N. Now, our R is 5, our N is 1. So 5 is equal to 3 times 1. So, but 5 is not equal to 3. So to complete that 5, we will need how many numbers more? That's 2, right?
Yeah.
So what it means is that this structure is indeterminate, and that 2 that is remaining, it is to the second degree. So when we say indeterminate, to what degree? We are saying second. This one now will be second degree. Now, I want us to now try this particular member we have here. This one looks clumsy, but if you have okay, you have seen it already. Now, this one looks clumsy. Why am I saying so? Because it's like a fixed and a roller support. What it means is that it can move like this, but it is restrained in this direction and restrained in this direction. So for this one, we have just 2 at this particular point, because it is not restrained from moving up or down. Now, however, if you look at this member also, we have a hinge at this particular point. And when we have a hinge, that means it's like if there's a shear happening in that particular position. It can break at this place. So we also have 2 unknown reactions at a hinge support. If you go to the beginning of the note, let me go to where we have hinge support. Now you can see a hinge, pin of hinge. You can see that we have 2 there. So it's in the note, but I just try to just clarify it for us also. So in this instance here now, we have 2 here, we have 2 here, and we also have 2 here, making 6 reactions altogether. Now, where it gets interesting is number of members that we have here. We have this member 1, and we have this member 2. Because this one is in, it can be distorted, or it can be let me say, dismantled into 2 places. That's why we have a hinge here. So, or a pin that is just holding that particular place. So example of where we have this kind of a thing. Let me look at. Okay, I think I have an example that I can always set. Let me turn on my camera for the other one. Okay, look, let me just on my camera. Hold on. Can you see me? Oh, that one's not clear enough. Let me use the other camera. Can you see my other camera?
Yeah. But it's not showing anything.
Okay. Yeah. Can you see the other camera? On the
The
other
camera is not
camera, can
showing.
you see it?
The camera is not showing, sir.
The second one. I'm using to account there.
I can see one, but the other one is not to show anything.
I'm seeing it here now. Can you see Dr. Ali Adekunle on the among the members?
Yeah,
Yes,
I can
yes,
see it now.
Yeah, you can see this member that I have here.
yes.
Yeah,
You can see the way I bent it.
yes.
Even though it's a single unit like this, but it is hinge at this point.
Yes.
So I can bend it like this. So I have two members. Member two. Even though it's just a single structure. So that's an example of this particular member that I have here. Let me disable my camera. Okay. So for this one, we have two members, member one, member two. So it is pinned at that joint, and that's why the structure is standing. Now, when we need to determine this, is determinacy using that equation that I told you the other time, that R is equal to 3n, R is 6, is equal to 3 times n is 2. So 6 is equal to 6. That means the structure is statically determinate. Now, I want you to look at this particular one before I reveal it. How many members do I have in this one?
We have three.
Very
Three
good.
members.
Very good. How
Three
many
members.
reactions do I have here?
We have three there.
Yeah.
We have three, two.
We have three also there.
Yeah.
Gbàlejò.
Fix N.
Mi ìsọmọ mo fún ti ń gbàlejò. Lẹ́tọ̀ sí.
How many do we have here?
Three.
Very good. What of here?
Two.
Here and go.
That's two again.
So we have 3 unknown reaction here. We have 2 here. We have 2 here.
Two
And we
there.
have 3 here. So if you sum everything, how many reactions do we have now altogether?
10.
Very good.
10.
But how many members do we have?
1, 3.
Very good. So that's what we have here. Our R is equal to 10. Our N is equal to 3. So if you do that, R is equal to 3N. You have 10 is equal to
Kò sí bá
3 times 3. That's 9. So how many numbers is remaining for you to complete 10? 1. So that means it is statically indeterminate to the first degree.
First degree.
Any question before I proceed?
No question yet.
There's question. Is there no question here?
No question.
There's
I don't
question.
have.
Okay, ask your question, please.
Okay.
Hello, sir. Yes, sir.
I'm with
Come on,
you.
sorry, sir. Please, yes, sir. I came late. I didn't get the determinant very well. The way you calculate it from the center of the last one, you say this one is 3 and this other one is 3.
Did you
And
join us from
I
the beginning of
understand
the
it.
lecture?
Yes, my network was very bad.
You didn't join us at the beginning of the lecture. That's why you're having this problem.
Yes, the network was very bad where I am. I just moved to somewhere else.
Please, when we have a lecture, if you don't come on time, I won't be repeating myself because the time is short. Now, I
No
told you
problem,
at that time that depending on the support condition, we have various number of unknown reactions. And I told you that if it is fixed support, we have 3 unknown reactions. If it is a pin support, we have 2 unknown reactions. And if it's a roller support, we have just 1 unknown reaction. So, and I explained to you, I showed you example of a fixed support, which is this one. And I said, this is an example of a pin support,
Yes.
and this is an example of a roller support. Also, you can see different diagram. Maybe they will draw it like this. Sorry, my hand is not straight on this one. They can draw it like this for a roller support. Or they can draw it like this for a pin support also, like we have here. Sorry. Math is not too clear. So you can have this kind of for a pin support, you can have it like this. And for a roller support, you can also have it like this. It's not only like this that you'll be seeing for a roller support. So I think I can relate this. So let's be fast and move to the next segment. Now, the alternative B, the second method that we can use is this. That especially when we're dealing with beams and frames, we can say 3M plus R is less than 3J plus C. Now, what is R? What is M? What is J? And what is C? That R is the number of support reaction as we have been using earlier on. However, the C is the equations of conditions. That is, it is possible for us to have a roller support and it's possible to have a pin support. Now, what is the equation? What is C for a roller support? For a roller support that is at the internal member, we have 2 equations for that. And for a pin support, we have 1 equation. That is, our C will be 2 for a roller that is in the internal structure of the member, while our C is 1 for a pin at the center of a member or that is joining a member. Now, M is the number of members, while J is the number of joints. We'll do an example and see what we mean. Now, you see this one. You can see that on either side of this support, for this particular one, unlike the first example we did, when we have a support like this, we'll count this other side of the support as 1 member and we'll count this one as another member. Let me explain again. Unlike the first example we did, in the first example, this is a single member, right? But in this alternative B, we take this one, and where we have a support, anyone after that support is a member, and the one in front of it is another member. So for this one now, we have member 1, member 2. The reactions, this is a fixed support, we have 3 here. This is a fixed support, we have 3 here. This is a roller support, we have 1. If you have 3 plus 3 plus 1, that's 7. Now, the question I want to ask, is there a pin in this member? Is there a hinge in this member?
No.
Inside the member, there's no hinge. That is why our C is equals to 0. But joints, how many joints do we have? We have 3 joints. Joint 1,
3 joints.
joint 3,
Joint 2, joint
or where we have our support 1, 2, 3.
3.
You can see that this one is different from the other one. So
Yes.
if I were you, I will master a particular method and use it, except you state that using so, that's when you will be using each other one. And I would advise you not to mistake it for one another. Have understanding of the different method. I think that there are 3 alternatives. So this particular one I'm doing, you have to have understanding of it. Now, once you have been able to identify this particular number of reaction, number of member, and the C and the J, your problem is already solved. So all you just need to do is you apply this formula to determine whether it is stable, whether it is determinate or indeterminate. So we have 3m plus r. When it is less than 3j plus c, it is unstable, statically unstable. But when we have it to be equals to this, it is statically determinate. And when it is greater than it is indeterminate. So when we talk about indeterminate, then we'll be looking at to what degree. So let us go ahead and do this simple one. We have 3m. What is our m? M is 3. We have equals to 3j plus c. What is our j? Number of joints. 1, 2, 3. So 3 times 3. So by the time you do this calculation together, plus c, our c is 0. So by the time you do this calculation together, we have 13 to be greater than 9. What it means is that it is indeterminate, but to what degree? The difference between the two of them is 4. So that means it is indeterminate to the 4th degree. Now, having that understanding, I want us to check this one. In just a minute, let us see what you are going to come out with. Don't do that one by yourself. Let us see what you are going to come out with. Fast, please. You see alternative B.
The going to be 6, M is going to be 3, then J is going to be 4. 1, 2, 3, 4, 5, 6. That's it.
1, 2, 3.
So how many R do we have?
6.
How many M?
M, 3.
How many C?
3.
How many J?
J
Now,
will have 4.
4.
You can see that once you are able to write this number of reaction, number of members, the C and the number of joints, your problem is solved. Easily you can determine whether it is determinate or not. So it is being able to identify all these particular unknown before you be able to determine whether it is indeterminate or determinate. Now, all these determinate or indeterminate that we're talking about, when we want to analyze a structure, if it is determinate, that means we can use our normal principle of summation of forces along the x-axis to be equal to 0, or summation of forces along the y-axis to be equal to 0. We can use it to solve those particular members' problem, to know what force is going to be applicable in each area of the members. However, when the structure is indeterminate, what it means is that we cannot use that basic principle of summation of forces along x-axis to be equal to 0, or summation of moments to be equal to 0 to solve that member's problem. That is why we are going to use different methods in analyzing that structure. You must have been hearing something like moment distribution method, slope deflection method, Clapeyron, matrix equation, and the rest. All those methods, they are used in analyzing structures that are indeterminate. Are you getting me?
Yes.
Yes, sir.
Okay. So that is why we are checking whether it is indeterminate or determinate. If it is determinate, we can easily solve it using the normal calculation that we already know. Summation of forces along S is this and that. But when it is indeterminate, we have to solve it using those analytical methods. And we have different methods which I've explained already, which I've talked about already. So most of the structures that we are having, like our continuous beam and the rest, many of them, they are indeterminate, and that's why we have to use moment distribution method or slope deflection method to solve those ones, to resolve the moment and the shear in those components. And if you look at it very well, or like now, most people are using software to analyze structures. If there's no understanding of the basic principle, they will not be able to write those software, and they won't be able to solve those things. So at times, it's possible for you to have a software that will give you an error, but you should be able to check it yourself and see whether what it's saying is realistic or not. I think my time is almost running out. I will rejoin again after if we have been cut out. So let us proceed to the next one. Yes, we have an interesting one here. Look at this one now. You can see here we have a pin support, roller support, and roller support. So we have 2 plus 1 plus 1 plus 1. That's R is 5 altogether. However, if you look at this very well, you know, we always say the number of members is the one in each support. But looking at this one, like the example I told you the other time, when we have a pin support here, what it means that from here to here is a member on its own already. From here to here is also a member on its own already. So if you are not careful enough, you might think this is just 3 members because it is pin or hinge at this point. It is no longer a single member, it is 2. So your member now will be 1, from here to here is 1, from here to here is 2, from here to here is 3, and from here to here is 4.
Oh.
Now, I told you the other time that our condition of equation condition, that we have two equations for one internal roller, and we have one equation for each internal pin. So for this particular one now, we have just how many pins?
1.
So our C is 1. So adding it is a roller here, our C will be equal to 2. Any question? Now, the other interesting part is that number of joints. Somebody is supposed to say joints. We are not going to say 1, 2, 3, 4. No, it can't be 4 because this place is another joint on the same. That's why your J is 5. So I want you to just look at it very well, understand it, and ask questions on this before I proceed. Don't let me waste much time on this. Let's proceed. I believe everybody can do the other calculation after being down. Now, this is another interesting part. It says, when using alternative B for classifying a frame, this is an example of a frame. The frame must be disassembled at its joint to correctly determine the number of members. Now, if you see this one now, we have joint here, we have joint here, we have joint here, we have joint here, joint here, joint here. If we disable it, we are going to have this side as 1, this one as 2, this one as 3, this one as 4, this one as 5, this one as 6, this one as 7, this one as 8, and this one as 9. That's the number of members. So even though it's a frame structure, you have to disassemble that way to be able to know the number of members. And this one we already know is 2. So we have 2 plus 2, that's 4. So we have 4 reactions We have 9 members. Our C is equal to 0. Let's go and look at the joints. How many joints do we have here? Somebody will say 1, 2, 3, 4, 5, 6. We are supposed to be having 6 joints.
There's 7, 8.
But this place is a joint. This place is a joint. That's why we're having 8 joints. So don't do that mistake. Always check very well so that you don't mistake. But once you're able to write this visualization out correctly, your problem I hope my voice is not breaking.
No.
Okay. Now, the other one is alternative. This one look almost like the other one, but the equation is different. And I will give on this. If you look at this one, it looks like the first one that we did. This one is R plus FI. As you already know, our R is the number of support reactions. Our M is the number of members. But this F is the number of reaction forces that is transmitted by an internal heat or internal ruler. Now, let's take an example. Just like the first one we did, a single member. In alternative B, how many members are we going to call this one?
Sir, your voice is cracking and it's just repeating.
Okay, sorry. Maybe I should stop this other one first. Sorry. Hello. Is it okay now?
Clear enough, sir. Very well.
Okay. Now, in the alternative B that we did at that time. Okay. Hello?
Hi.
Okay, yeah. In the alternative B that we did at that time, this particular that said this number of members. We would have said this is 2 in the other thing. But in the alternative A, this is a single member. So this one, like alternative A, this is one like single member. Now, the number of reactions transmitted by an internal hinge, internal ruler. There's no internal hinge or internal ruler yet. So it's still cracking.
Yes.
I don't know why it's cracking, but okay. Now, for this particular one, number of monoreactions, we have 3 here, 3 here, and 1 here. That's why it's R is there. And the number of members is 1, and FI is 0. So if you apply the formula, R plus F to be less than 3M, our R is how many? 7. 7 plus our F. Do you have any number of internal hinge? No. F 7 plus 0 equals to 3 times what member? 1. 3 times 1. 3. So 7 is greater than 3. So it is indeterminate to 4th degree. So apply that one. Let me go to inch. So this particular one now, we have an inch. Because we have an inch, we have member 1, member 2, and number of reactions plus 1 plus 1. Or maybe everybody will move to their own mind. Let's see.
Let's see
Now, as I was saying, the number of reaction here, we have 2 here, 1 here, 1 here, and 1 here. That's 5 altogether. But the number of member is 1, 2, because we have a pin here. And because we have a pin, we said something the other time, that when we have a pin, the number of reaction forces transmitted by an internal hinge or roller, that's Fi. Now, for this particular one, we have